Well, hello everyone. James Staten with Forrester Research here again, and we're going to get started on this presentation because I want to be respectful of your time, and I appreciate again you participating in Cloud Slam and coming to this session in particular. The topic of this session here today is going to be about how to turn on cloud economics. We're going to be focusing mostly on uses of infrastructure as a service and platform as a service platforms. So the former good example, of course, is Rackspace. The second would be Microsoft Azure or Force.com. So let's get started. The theme for this presentation falls into these two things. We all know that scale out turns on cloud economics. What we're going to talk about here is how scale down turns on cloud economics in a greater way. So if you put something in the cloud, you're activating it, which means you're starting the bill. The key to any pay-per-use platform is to get that bill to turn in your favor, meaning going off, going down, and adapting and adjusting as your traffic flows and as your demands adapt. That's kind of the key thing that you're going to get out of this presentation, I hope. Now let's look particularly at the most commonly cited example of a cloud application. Netflix is a great example of really using the cloud and turning on its economics. It's important to understand why Netflix has moved to the cloud, and it has a lot to do with the tremendous growth that they're under. And so we're talking about a business that's highly elastic, and therefore applications that have high elasticity would be a nice fit here. And in order for them to take advantage of the cloud, they've really optimized the key services that they've put on the cloud in order to get the best cloud economics. So let's look at those services separately real quick here. The first one they've talked about quite a bit is the movie encoding capability. So they receive a movie from a Hollywood distributor in a single format, typically a Blu-ray DVD or something similar to that, and their job is to then upload that movie and convert it into multiple formats that are appropriate for the different types of phones, different types of devices that you would be connecting into, but also the bandwidth type that is available to you, because they want you on any device in any circumstance to have a good experience streaming that movie down to you. So they have to really do a whole lot of permutations. This takes a huge amount of storage. It takes a whole lot of compute power to do these conversions, and they found that these are very bursty, and as a result, they're a good fit with the cloud. The second major service is the actual streaming of the movie once it's been converted. And they talk very much about using the different content delivery networks that are out there, including Amazon's own CloudFront. And they talk very much about the growth of this service and how this service is going to continue to be a huge part of their business going forward. The third big service they talk about they've moved up to the cloud is their business intelligence system, which mainly does log analysis. And they talked about re-engineering this from ground up to scale out using Hadoop model and taking huge amounts of data and being able to very quickly analyze that, but then pour it into a data mart so that they can do further analysis that's not needed in real time. And the big reasons why they moved out to the cloud, well, one of the big reasons that they cite, of course, is that they didn't want to have to build a bigger data center to accommodate all their greater scale, and they felt that they could get greater economies of scale by elastically tapping into someone else's resources rather than having to build a core competency internally of managing their own data centers. Very different thinking from what we've seen recently from Facebook, who has decided they are going to have their own data center, and that very much has to do with what they see as a very large and growing baseline application use, whereas that's not necessarily the case for Netflix, which is very transaction-oriented in how they use the service. Now, if we take a look at how these three applications turn on cloud economics, we get a picture that's very much centered around the more they optimize the cloud, the more profitable their service is, because their service is very much an electronic experience, but an experience you come and go from. The subscription value comes from coming back to it more often, not having it up and running for you all the time. And so they want to make sure that when they're streaming to you, the resources are there. When they're not, the resources are turned off or as close to that as possible. So looking at these three services, what you end up with is a model like this. For movie encoding, this is very batch-oriented. Hollywood tends to release movies sort of during one day of the week. A lot of studios, for example, release them on one day, like a Tuesday, so they can be converted. So as soon as they receive that movie, they want to fire up as many resources as possible to create all of those permutations as they can, and as soon as those permutations are done, they want to get out. And so you see a circumstance in which this really isn't that time sensitive because they can't release the movie to their subscribers until the Hollywood contract says that they can. So they get a fair amount of time up front in which to get prepared for this, and so they can pick the right times to do this. This allows them to take advantage of low cost and low resource availability windows inside of the cloud. Amazon makes a capability called spot instances available in their cloud, which says that if there are a certain amount of instances of extra capacity they have available, they'll drop the price on those to attract someone who doesn't have to be there right then and there. By tapping into spot instances, Amazon Netflix can reduce the cost of every VM they fire up in Amazon by a fair amount. They also very much are optimizing the storage formats of these final converted video files so that they can keep their S3 costs low. And there's more things they're doing with storage on the back end, which I won't go into at this point, but you certainly should explore that with Netflix if you get interested in that topic. On the video streaming service, all the movies are stored in S3 and then passed out to the multiple CDNs. This is a really smart move because CDNs will charge you for the amount of content you want them to hold on to. You can control that cost by not having them store the movie, but having them retrieve it from somewhere else. So this is a good way to control their costs in the CDNs by leveraging cloud as well. They're also being very clear about identifying the user, the type of connection the user is coming in from, and making sure the right stream goes to the right CDN for distribution to that user. So a lot of optimization is going on here to keep CDN costs low and do a trade-off between CDN costs and the cloud cost, but try to keep both sides as low as possible. When it comes to log analysis, taking a very big data warehouse and putting it in the cloud is a really bad idea. So they had to re-architect from the ground up in order to get BI into a model that will elastically scale and won't consume a significant amount of resources all the time. And so that's the big reason that they decided to do a complete rewrite of the application. The key thing for them is to be able to understand new patterns that are happening by their users through the users' interactions, through interactions with their friends, the types of movies they're getting to, and making sure that as soon as they have finished watching one show or one movie, that they can immediately update the recommendations to that user and get them to pick the next movie and use that again. In other words, keep the subscriptions high in the service. So the business intelligence is critical for the recommendation engine. It's critical for making sure that they have the right type of experience, that they can give feedback on the movie right away, they can tell friends about the movie they've interacted with. All this stuff is important for them, and it's all through log analysis they identify these patterns. So thinking about how they are doing the things they're doing, let's look real quickly at the economics of cloud. What I'm going to go through now, most of you probably know, so I'll go through it fairly quick. We all know that if you have an application, you can make it scale out. That gives you just-in-time capacity, giving the ability to turn on the cloud. Because it's pay-per-use, you have no base footprint, you have no base cost that's there all the time. You don't have a long-term contract, which means you're paying the same every single month. Those are some basics of cloud computing that are really critical. And then if you can write to a programmable API, or if you can work through a very simple-to-use user interface, or use open-source tools or third-party tools like Chef or RightScale or Puppet, you can quickly and easily be productive on your own and get things into this environment. There's no calling your hosting provider saying, hey, I'm going to need some more capacity. Can you put it online for me? None of those things that would slow down this process exist in the cloud. And that's very much what allows cloud economics to be turned on to begin with. So these basics are typically well understood. What's typically not as well understood is how you then turn these economics into your favor. The key thing here is when we talk about elastic scale, it's not that you can scale up that's so critical. To turn cloud economics on, you want to be able to turn resources off. So it's great that you can use load balancing to identify an increased pattern and fire up additional instances and make them available to accommodate capacity. But the moment you see that pattern go the other way, you want to be able to turn off those instances as fast as you can and shrink back down to an appropriate baseline as quickly as you can. Lots of ways to do this. Obviously, the more you script to the load balancer, the more performance monitoring you do. Those are big benefits and a lot of ways to do that. But you can also leverage caching here, and by leveraging caching, you can prevent the need to bring on new instances necessarily so fast. You can accommodate content that is being re-requested and re-requested rather than have instances continuing to serve up the same instances. You can also do this to alleviate having to scale back-end components. So by leveraging caching, you can prevent having to fire up and scale out the database, for example. Instead, use an application cache layer. Do the same thing between the application logic layer and the web server, and you may be able to scale the web servers far more dramatically than you need to scale any of the app logic tier behind it. That also speaks to the next point, which is what you scale matters. So I talked about in a 3-tier architecture scaling just the web server and just the cache, so you don't have to scale the app logic and so forth. The second thing is to actually look at the app logic itself and determine what parts of the app logic are actually scaling and which ones are not. A lot of us have a tendency to write applications that have lots of different functions going on in the same application. In those cases, it's worth looking inside that application to see which of those functions are actually throwing off the most threads. Those individual components, if you have a big mismatch between components in that executable that scale dramatically and those that don't, you may be better off splitting that application into separate executables so that you can scale the piece that needs to scale independently on its own and leave the others small. These are some of the things you want to start thinking about in your application design. The more you know about the performance characteristics of your application and can use that in design re-architecting or in designing from the beginning, the better off you'll be in the cloud. The second thing you want to be paying attention to when you talk about what scales is where things exist. A lot of us are going to be building applications that live entirely in one cloud, but in other cases we're going to have those cloud applications call back to the data center, call back to an OLTP system, call back to an ERP system to retrieve information. Where traffic goes is really important because there's cost associated with that. Through a lot of the cloud solutions that are out there, if you make an extra cloud call, meaning a call leaving the cloud and getting data from somewhere else, you'll pay for that outbound bandwidth. In some of the clouds, you'll actually pay more to send data out than you will to bring data back. So that's another factor that you need to think about in your application design as well. So keeping an understanding of these characteristics also in your application design will help you architect applications more effectively. The other thing is sort of thinking about when you do things. So what is off-peak to you? That's something really important to understand. When there's an off-peak, you may be able to reuse resources for things that you can batch up, things that you can queue together, and try to streamline and optimize how the different parts of your applications behave and mix and match different applications and the resources they consume. We talked about how Netflix uses spot instances to control the cost of a batch application. You definitely want to think about that. Does it apply to you to do the same thing? All right. Now, when you're thinking about cloud economics, a simple way to think about it is there's essentially 5 tools that you can use to your advantage to get cloud economics to tilt in your favor. The first is time. We talked about this, when you do something and for how long you do it. It's a very simple thing to understand. If you have a good sense of your application performance profile or your user behavior profiles, time is a very easy component to turn on and off and activate. For example, if you're putting out an application that's going to be consumed within a single time zone during business hours from 9 to 5, it's very clear that you can set scripting that will say this instance or this application should be completely off outside of those hours or should be much, much smaller. If you happen to know when during the day it's most active, if it's active during the lunch hour because people aren't working on other applications and they're tapping into this one, then you want to be able to start firing up instances at around 11:45 to accommodate that noontime traffic spike. And then be prepared and even schedule, perhaps, that it starts to wind down around 1 o'clock, 1:15. So doing simple things like that under basic pattern understanding will allow you to control footprint size in the cloud very effectively. Componentization, that's the second key element. This is where I was talking about in an executable, are there some functions that are firing up threads and other functions that never do. Separating those things out into separate components allows you to turn the economics again into your favor. Best example I've seen of this is a customer who had a fairly complex application sitting in the Amazon cloud that required a large instance. So a large virtual machine was the base footprint for this application. And there were two functions inside that application that were scaling like crazy and causing the load balancer to bring up another large, another large, another large. By then going and looking inside that application, they took that one component that was scaling and found that component could actually be cut off separate from the rest of the application and would fit in a very small. In Amazon, a very small for a 12-month period is free. So that's really a good thing to be doing. They found that the component that would scale into very small, as you scaled it out, was another very small, another very small, another very small. What's the benefit? Zero cost, zero cost, zero cost, zero cost. That's a tremendous savings over 4 larges. And you want to start looking at these capabilities and where in your cloud and how the cloud prices different things in the service are you advantaged by going down a componentization perspective. Third thing to think about is service choice. Now, some of this might be what services you design and where you put those services, but it may also be what services are provided by the cloud provider that you can simply tap into rather than having to write that function yourself. And a lot of the services you would be tapping into, and this is particularly true in the platform as a service market, is you may be tapping into a service in which you don't pay a penalty for using more of that service. Now, where that's the case, for example, if you're using the App Fabric from Microsoft Azure, you can use a significant amount of App Fabric before you see a financial impact of growing that. Same is true when it comes down to caching. Obviously, you should write in some caching layers yourself. You may be able to take advantage of caching services that are natively provided within these platforms, and there may be cost advantages to using those capabilities. Finally, look at your code and make sure that your code is actually executing the way it should. We run into this problem a lot with the clients we engage with, where they have race conditions inside of their applications that are causing scale out when it doesn't need to scale out. It's not actual traffic that's causing this. They may have workflows that are not optimized, where a workflow is causing multiple transactions, multiple lookups, where simply a check against a cache would be appropriate, or where the lookups are not really necessary and they could be ganged together into a single request that goes over the wire. So you really want to pay attention to these key components here. These are your primary tools in your toolbox for turning cloud economics on for your applications and how they work. All right. Now let's go back to the Netflix example here. So if you look at these 3 services that are being provided here, think to yourself about the tools that you just saw on the prior slide. Which of these tools here is Amazon activating? When you look across these 3 services and you look at these 5 tools, which of these tools are they using within each of these individual services? For sure, we see time. Time is absolutely being used in the movie encoding. They don't have to encode the moment they receive a movie from Hollywood. They can do it at any time between receiving the file and being able to offer that file up to their subscribers. Componentization. When it comes to the video streaming service, this is clearly the case. So they've said that they're going to optimize which CDNs are used for what, where they're going to store the files, choosing to store on S3 rather than store with the CDNs themselves. You can also say componentization is present in the log analysis and business intelligence system, where certain components came out of their redesign. And some components scale faster than others, and some scale in a different way. Service choice certainly applies to to the video streaming service, where they use the options of what should be done where. A good case here is service choice, looking at the service that's provided by the cloud provider themselves. In this case, they are using CloudFront in certain cases. They're hosted on Amazon. There's cost advantage to using CloudFront in certain cases. They're identifying those and taking advantage of it. And certainly code optimization was in play in the re-architecture of their BI system. They obviously spent a lot of time looking at how do we re-optimize this in order to be effective. Now, clearly, code optimization is the one that's going to take you the longest to take advantage of. No one wants to go, open up their code and go through it line by line and do an analysis of threads and where things are flowing, but you can find advantages from doing that. So if you've got an application that you really think you could squeeze some additional value out of, it's worth it. But I wouldn't start there. I would definitely start by using the other tools that we talked about before. Let's look at another example here, Invoice Pay. So this is an example of a service that is running on Microsoft Azure. So as I said, these are techniques that work on infrastructure as service as well as platform as a service. So we're switching over to a platform example here. What Invoice Pay does, just so you know, is a bit about their business. Invoice Pay is a service for small, medium-sized businesses to do B2B invoices. And sadly, if you take a look at the B2B market, they continue to sort of do business with each other through actual hard checks. And that's a difficult thing for them and for financial firms that are trying to service them to meet, because it's just not efficient at all. And so what this solution does is allow them to have a SaaS implementation of a vendor payment system where basically they pay by the transaction or by the invoice that they generate, and this company, Invoice Pay, takes a portion of that. And this is a really nice, simple example of a good use of the cloud because it's replacing an on-premise solution. It's involving a variety of different providers in order to make this system work, which means that their service has to not only take payments but also integrate with other services. They don't have to do PCI necessarily, but the services they talk to clearly do. So they're providing a nice layer on top of an invoice system that's a bit outdated, and it brings it into the modern time. Now, this is an Azure-based service, as I mentioned, and it's one in which they needed to have 100% availability. So they went to a platform where they knew firing up multiple instances, protecting themselves from individual components going down, they could do in their own application design. Now let's look at how they activate cloud economics. The key thing for them is because they get paid a fraction of a penny for each invoice that goes through their system, they have to make sure that each individual invoice can go through as efficiently as possible and that they can maximize the amount of invoices they handle simultaneously. And in order to do that profit picture, you want to be able to handle as many invoices possible with as little a footprint in the cloud as you possibly can. And when you're not handling invoices, you want to be as tiny in the cloud as possible. So that's where their core philosophy for how they use the cloud is summarized in this line that you see here. If it's running, it's cutting into profitability. So they want to have this stuff off unless it is handling transactions. And the second it's not handling a transaction, they want it off or small. So over time and through the optimization, and why they're really tweaking and tuning all the time their services in the cloud, is to lower the cost of these payments. So that if they continue to get pennies per 40 cents of transaction, they want to make sure they pick up as many of those pennies and they keep as many of them as they possibly can. So that means scaling out only when necessary, as we talked about before. That means cutting down on traffic flowing in and out of the cloud because you're paying for that again. And they do a lot of things to make sure that happens. They do a ton of caching in their application design. They do a lot of batching up of requests so they can send them together at once. And they do as much as they can in the client so that they don't have to have a larger server-side executable in the back end. They also take advantage of a lot of the cloud services that are provided natively in Azure. So they're a heavy user of App Fabric. They use the Azure Blob, table and queue storage capabilities. They take advantage of the Azure Connect to do some secure connectivity between components and outside of the cloud, and they do as much client-side using Silverlight as they can. As a result, the key tools you see them using, time for sure. When we talk about batching up traffic, this is a circumstance in which they're saying, how quickly do I have to update the payment system? In their circumstance, they're producing invoices, which are going to take some time for somebody to read the invoice, process the invoice, and then pay it back. So they got a lot of time that's to their advantage, where they can take advantage of those lulls in the workflow to optimize what the cloud is doing during that time. So time is a key factor here. So in any kind of business any business process or workflow that you're going to be building applications for, think about where is time to your advantage. Where do you have time gaps that you can take advantage of them through application design and optimization? Next, componentization. This is a heavily componentized service where they understand what the thread counts and thread patterns are of various application components, and they're constantly looking at that to say, can I strip this application down even further? Can I get this down so that its base footprint, its base consumption of the platform as a service is very, very small? And the objective here, as I mentioned, if it's running, it's cutting into profitability. That means at any point that something doesn't have to be running, we want it not to be running at all. We want to shut it off. Another thing they're paying a lot of attention to, and them and other vendors are pushing on Microsoft and pushing on the other platform and service vendors to give them, is faster fire-up of new executables. So in these platforms as a service, in most cases, they're not having to fire up a full virtual machine. They're having to fire up a service within a virtual machine or within a non-virtualized environment. In those cases, those executables should fire up very fast. If I don't have to have anything running, but I can respond to a request in 1 second or 2 seconds, and an executable is up and running and going, that's a huge advantage. And that's one of the differences between the platform as a service and the infrastructure as a service. In infrastructure as a service, everything you fire up is a virtual machine, which means the VM, the operating system, the middleware, all that stuff has to come up and has to be fired up in the proper order. On these platforms as a service, you can get away with a much lighter footprint that's much faster to execute and bring up. Third, you can see that they're doing service choice. So in obviously the last bullet here where you see all the different Azure services they're turning on, these are components they didn't have to build. These are components that do tie this application to Azure. So there are some concerns a lot of customers have voiced in the past about that. They don't want to be tied to a particular cloud, but the reason that they're using these services is because they get productivity here. They don't have to write this. They can rely on somebody to provide that core capability. And if they had to move to another cloud, it would probably be fairly painful to do, but most of their application is written in C# or is taking advantage of Silverlight or other executable code that can be picked up and moved to another service. So in this case, service choice for them means I get a lot of cost efficiencies when I activate these services rather than writing them myself. Caching is a huge part of their architecture here. I talked about the caching to prevent various components from having to fire up. That's a key part of their strategy. You're going to hear, if you talk to Invoice Pay, you'll hear even more about where they're putting caching, and they're pretty much putting caching everywhere they possibly can. Anything that allows the system and service to respond, to read requests, and does not require a component to fire up is in their advantage. So, some simple recommendations, and then we'll get to Q&A. So if you have a question for me about this or about the examples I gave or any of that, start firing those questions over to me now, and I'll be able to address them as soon as we get through with these recommendations. Simple things. Number one thing, and this may be difficult for you or maybe new kind of thinking for you, understand what the profitability profile of your cloud service is going to be. I know a lot of us that have a programming background or mostly are programmers or infrastructure and operations professionals, we sort of know how systems work from a performance and availability perspective, but we don't always know how the company makes money off of the applications we build. That's critical. In the cloud, you really do want to understand what the profit profile looks like of your application. If there's anything you're firing up, if there's any resource you're consuming, you're incurring costs to the company, and those costs cut into profitability day one. So it's really important you understand where profit is made, where profit is not made. Now, what's a set of resources that you should be having turned on because they allow revenue to be generated in the first place? What components and resources are being turned on that are actually generating money? So you want to be understanding that model so that you can tune and optimize your use of the cloud to maximize that profitability. So you're going to get real close to the business by using the cloud. You probably already are close to the business. This will get you even closer. Once you sort of understand that workflow and you understand where profit comes from, then you want to take a look at how the business process works and what things inside your application are used to make that business process happen. And take a look for anything that's extraneous. Is there anything your application is doing that really isn't tied to that process? Maybe it's monitoring that you're doing, it's a log, an audit trail that you're putting in place. Maybe there's components that you're firing up that you thought were part of the business process, but now that you understand it, they really don't play a role. Look for those kinds of things and make your optimizations at that point. Those are going to be huge for you. Take a look at the performance profile of your application. We all have done performance analysis. We all know how these tools tend to work. They're very applicable in the cloud. You want to be looking at your thread structure. You want to be looking for race conditions. You want to be looking for anything that would suggest that your application either has a base footprint or has a scalability profile that does not match actual customer use or actual use of this product or does not match the workflow. Anytime you find those things, there may be justification for them, but if there isn't, strip it out. Change how that works. From a scalability perspective, you really want to focus on, with your load balancing, how do you get the load balancer not just to fire things up when it sees patterns going up, but how quickly it can fire them back down when the pattern reverses itself. So pay good attention to that. Using tools like RightScale, using other tools for workload management, workload automation, you can put some processes in place that will turn these instances off faster. And it will allow that to happen in a more consistent fashion. So pay attention to all that stuff. Application timing and how actions take place is really important to focus on. And you can get a lot out of it by doing that. Then you want to take a look at the services that are provided from your cloud. Does your cloud provider have the ability to do granular control over load balancing? Do they expose you directly to the F5 interface, for example, and you have skills in F5? That would be something to tap into for sure. Does your cloud provider have a caching service like CloudFront that's built into the service? How can you get great advantage out of that? How granularly can you take advantage of that service? Take a look at reusable components. Are there components that you have fired up that you don't need to fire additional instances up, but by re-architecting your application, can that service be shared and used by others? Messaging and queuing is another good example. If your cloud provider has a standard position in place, tap into that. How can that benefit you? What capabilities are built into the cloud platform, and talk to them about the roadmap. Talk to your cloud provider about what you're trying to accomplish, and there may be something on the roadmap coming down that's going to address your specific need, or you may be able to influence them to change the roadmap to accommodate your needs so that you can get some of these advantages. And then sort of as you learn, make sure that you bake these into your architecture, bake these into what you put forth as best practices for the next cloud application your company is going to bring forth. If you understand the 5 tools that I laid out here, maybe you want to put those into the best practices. Hey, every developer who's going to build for the cloud, know these 5 tools, know how to leverage them. Maybe you just want to focus on time and how can we use time to optimize. You may want to put that in place and make that available. It's important that you try to have a consistent architecture as much as you can when you're going into the cloud so that you have a lot of reusability. That's going to be critical as you mature your experience here and as you do much more with it over time. So hopefully this has given you a good sense of how to activate the cloud. Forrester and we are very interested in your experiences. As you find benefits from these things, contact us. Let us know what you're doing, how you took advantage of it, and where this came from. We also have a variety of research on different topics around cloud, whether it's this topic in cloud economics, whether it's how to build a business case to your company about whether you should have cloud or whether you should put things in the cloud, or specific case studies, other companies that have tapped into the cloud and how they did that. Feel free to reach out to us for all of those types of topics. So with that, I think we've got a fair amount of time left over for some questions here. So feel free to fire your questions into the Q&A box at the bottom of the WebEx, and I'll be glad to take them. I think we may be able to do them over the phone as well, but I'm not 100% sure on that one, so I'll leave that to the host here. Hopefully I haven't lost you guys with the depth of this presentation. Well, it doesn't appear that we have any questions coming through on the WebEx. I do appreciate everyone's time and attention. Pay attention to this presentation. I hope that it's been valuable for you. You see my contact information on here. Feel free to reach out to me if you have further questions. Email, in case you need it, is jstaten@forrester.com, and I'll put it down here in the Q&A panel so that it's available to you.